Welcome. Today we'll explore an interactive cloud-hosted notebook designed to demonstrate how databases are used in drug discovery. This hands-on guide focuses on accessing and working with drug-related data, with a special emphasis on the Chembel database and its Python tools. This interactive Jupyter notebook on Google Colab includes text and code cells. We'll start by installing the Chembel Web Resource Client library for accessing Chembel data. Please allow a few seconds for installation. Now, we'll import the library and proceed to the exploration section. This section demonstrates how to explore the various data entities in the Chembel database using the new client object, giving access to detailed information on molecules, including names, synonyms, structures, and properties. We'll start by retrieving a list of all data types available for exploration in Chembel. This code lists accessible entities, such as activity, assay, binding site, drug, mechanism, molecule, and more. Note that attributes with underscores are for internal use and typically aren't accessed directly. Now let's explore the molecule data entity in Chembel. When we access newClient.molecule, we get a dictionary with detailed molecule information. Some of the attributes include ATC classification codes for the molecule, the availability status, the biotherapeutic properties, indication of black box warnings, unique Chembel ID, molecular properties like weight and bond counts, structural formats like SMILES or alternate names for the molecule. Next, let's create a molecule object that allows us to interact with the molecule data entity directly. To retrieve specific molecules, we'll use the filter method on this object. For example, let's search for all molecules in Chembel with the synonym name aspirin. We use the iExact lookup, which ensures a case-insensitive exact match on the synonym name. The resulting object will contain a list of all molecules that match aspirin as a synonym. Not easy to read? No problem. You can convert it into a pandas data frame for easier viewing and manipulation. For added flexibility, you can even export this data to an Excel file for further analysis. The scenario-based exercise section presents a scenario where a researcher receives a compound with only a structure diagram. The exercise involves converting the diagram to a SMILES string, searching the Chembel database using this string, and analyzing the results. First, let's convert the structural diagram of the molecule into a SMILES string, a text format that's widely used to represent chemical structures. There are several tools you can use for this, such as the NCI's online converter, which can quickly interpret your diagram into a SMILES format. Now that we have the SMILES string, we can use it to query the Chembel database for detailed information on this specific compound. To do this, enter the SMILES string where indicated in the code, as shown. We then export this data to an Excel file, making it easy to analyze further or share. From here, you can download the file and examine key details about the compound, such as its classification, properties, and related studies, directly from Chembel. This process allows us to gather a comprehensive profile of the compound efficiently. As a bonus exercise, the notebook challenges users to create an Excel file containing all withdrawn drugs listed in Chembel, further reinforcing the skills learned in the tutorial. The notebook concludes by explaining the concept of canonical SMILES, a unique representation of a molecule's structure and its importance in database searches. It also includes code for generating canonical smiles using the RDKit library. This Jupyter Notebook serves as a valuable resource for the users interested in learning how to utilize databases in drug discovery. By following the examples and completing the exercises, users gain practical experience in accessing and analyzing drug-related data programmatically.